All right, guys, so we are looking at section 10.2 today. Guys, as always, just like any typical class lesson, if you have questions, please ask, right? And I'm not looking at the chat while I'm doing this, so don't put something into the chat because I won't see it. So if you do run into a question or if there's any issues, please speak out and let me know what's going on. But otherwise, we're going to be going through this, this first page, and then we have a backside to this as well, where we're going to take a look at arc length. So far, pretty much the main thing that we looked at in lesson one, as we just started introducing circles, was just a couple of main ideas, such as we know the degrees around one full circle is 360 degrees. We talked about the circumference of a circle. So remember, circumference is basically perimeter. They just don't call it that when it's a circle. They call it circumference, but it's still perimeter, right? We're measuring the distance around the outside of the circle, right? That's our circumference. And so we're going to use that a little more today as we get into this. So let me throw a couple vocab words at you to get started. A central angle is an angle that is formed with the center of the circle, right? That's why they call it a central angle. So if you looked at this angle right here, we'll just pick on this one, right? What's something we might call angle E here. So if we put together angle CEF, so if we were referring to this angle right there, that would be a central angle because the vertex is the center of the circle. So that would be a central angle. If you go straight out from that central angle, you get this that we call arc CF. So an arc is simply the outer portion of the circle that matches up with that central angle that you see right there. Okay, so this would be arc CF. One of the things we'll be getting into in just a minute here is the length of the arc and the measure of an arc. Whenever you talk about the measure of an arc, then we're referring to its degrees. Whenever you talk about the length of an arc, now we're talking about like its literal length if you were to measure it with like a ruler or something like that. So one of the first things we run into on this is the measure of an arc is the same as its central angle. So if that angle right there happened to be, let's just say 40 degrees, then arc CF would also be 40 degrees, right? So just like these central angles would always add up to 360 degrees, then the degrees of all these arcs would also add up to 360 degrees. Right, and so one of the main things we're looking at today is that the measure of a central angle is equal to the measure of its intercepted arc, like arc CF. If you get, and a little more vocab for you, if you get an arc that is more than half the circle, so if it's more than 180 degrees, then we call that a major arc. So that's this guy. So if CHG, so if you look right here, so if we said arc CHG, since that is more than half the circle, we call that a major arc. If you get one that is less than half the circle, so like GF, so this little guy right here, that's obviously less than half of the circle, that would be a minor arc. If you get one that is exactly half the circle, so if you get an arc that is 180 degrees, we call that a semicircle. So guys, all that I just said is in these bullet points right here. So you don't need to necessarily write all that down separately. It's all within those bullet points that you're seeing. All right, let me go down a little bit. So we're going to start by looking at these first two exercises. So a lot of these are just going to be identifying a value for X, whether it's a central angle. Some of these is going to be the measure of an arc, but we're just kind of identifying the degrees of all this stuff. So guys, everything on this page that you're seeing in front of us, they're all talking about degrees. So obviously if we're talking about a central angle, that would be measured in degrees. And what you're seeing down here where it says the measure of an arc, a measure always refers to degrees as well. So all these go back to degrees. And the two things that you can sort of focus on a lot are the total degrees of any circle has to total 360. That's one of the biggest things that we use all the time on these. The other thing is if you have a diameter, so if it represents half of a circle. We know half of a circle is 180 degrees. So we want to keep that one in mind as well. But for these first two, we're just going to be focusing on the total measure being 360 degrees. So that means if you were to look at this one right here, I know that if I took all four of those central angles and add them together, I know they need to total 360. So that means if you're going to write an equation, we could say something like that x plus 105 plus 60 plus 115 is 360. So all four of those put together should add up to 360. And so that gives us a little equation to solve so that we can just solve for x. So in other words, if I were to take those three angles, subtract them from 360, that would tell me what is left over for our missing central angle up there for x. So if we subtract those guys from 360, we're going to find that x is equal to 80 degrees. All right, let's do the same thing for this one here. You'll notice on this one that there's only three angles, which means all three of them should add up to 360. But they didn't tell us directly what the degrees of that central angle is. But we know by the markings that if that's a right angle, well, we know the measure of a right angle is 90 degrees. So we can fill that in. Now we can set up an equation, excuse me, just like we did on this first one, where these three values must add up to 360. So we got the x, we got the 90 that we filled in, we got the 120, and those guys make up one full circle, so they have to total 360 degrees. So again, a little subtraction, and we'll get our value for x. So if we subtract the 90 and the 120 from 360, we'll be left with our value for x, which would be 150. Guys, when you're doing problems like this today, as always, make sure you show work. So anytime we can set up some kind of an equation and show a process for how you get your answer, we always want to make sure that we do that. All right, let's peek down at these guys. Guys, again, recognize that when they put a little m right there, that means the measure of an arc, which means degrees. So the one thing that we looked at up above is if I have a central angle, so this central angle is 44 degrees, that means its intercepted arc, which would be AB, is also 44 degrees. So let's just go through for a minute and fill out some missing information. So if that's 44 degrees, then we know that arc AB is also 44 degrees. And one of the things that they threw into this that we hadn't seen for a long time is this takes you back to something we looked at first semester. These two angles, this one and this one, are vertical angles, right? So if you take, I got this diameter and I got this diameter, since these two angles are formed by the same two lines and they're directly across from each other, we know these would have to be equal as well. So vertical angles are equal. So that is 44, which means his arc is also 44 degrees. Okay, here's one of the new ones that we haven't looked at yet. So take a close look at this one. When you get the diameter of a circle, like we have on this, I'll kind of block this off so you can see it. So let's just focus on BD for a minute. So BD is a diameter. And we know that diameters are half of the circle. So if I have half the circle, then I know this total should be 180 degrees. So if that's 44, what would our missing arc have to be in order to get a total of 180? So if we did 180 minus 44, that tells us that this guy is 136. So the central angle would be 136, and its intercepted arc would also be 136. So we could do the same thing over here, because BD is also, if we look at it this way, separates that half the circle. And so I'm going to get that same 136 on the other side. Not to mention they were vertical angle, so we could have seen it that way too. All right. So now that we have all that circle filled out, this is going to be super easy. So if we look at the measure of arc BA, so here is BA. We've already identified that it's 44 degrees. One of the other things they've asked us to identify on this is that a major, a minor, or a semicircle? Well, remember, if it's less than 180, it's a minor arc. So this would be a minor arc because it's less than 180. Guys, when you run into these in a homework assignment, make sure that you identify that as well. So if they want you to not only give its measure, but also identify what kind of an arc it is, make sure that you do both parts. Let's just kind of keep going down the list here. So arc CD we already identified is also 44. We've already done the hard work here. Just got to fill in the numbers. All right, let's go down to the measure of BCD. So take a look at BCD. So we're starting at B and we're ending at D. So we already know that this is a diameter because it goes right through the middle of the circle. So if I just add these guys together, we already know they're going to add 180 since BD is a diameter. So if it's exactly 180, we know that is a semicircle. Guys, I want you to notice the difference on this. Why did they use 3 letters instead of 2? Well, any minor arc can be used with only 2 letters. But as soon as you hit the 180 mark, you now need 3 letters. Otherwise, we wouldn't know which direction to travel. If they just said arc BD, well, we wouldn't know if they want us to go this direction to get to D, or if they want us to go this direction to get to D. So they put in that 3rd letter, the C, to tell us to travel this direction to get that 180. So what you're going to find is typically anything less than 180 is going to be identified with 2 letters. But as soon as you hit the 180 mark or bigger, they're going to throw in 3 letters to tell you which direction to travel. So let's look at this one. So I'm already expecting this to be a minor because they've only used 2 letters. So we want to take the short route from B to C. And we already identified that that's 136 degrees, which is a minor arc. So ACB, and again, I'm expecting this to be a major arc or a semicircle because they use 3 letters. So we're going from A through C, and we're going to end at B, right? That's what these letters are telling us to do. So start with A, end at B, and we need to make sure that we pass through that middle point, point C. So how do we figure out the total for ACB? Well, there's 2 ways you could do this. I could just add up the parts. I could say, well, it's 136 plus 44 plus 136, and that would work out just fine. So if you wanted to add those 3 numbers together, you could certainly go that route. It would be a total of 316 degrees, which is obviously a major arc. But there is maybe a little shortcut to that. Instead of going from here and adding up all those numbers, couldn't we just say 360 minus 44? Right, we know this total is 360. So instead of adding up all the stuff that you do want, it's not a bad idea to just say, well, let's just do 360 minus the one value that I don't want. And that would also give me my 316. So you could go that route, and that would work too, whichever way you see better. One last one, the measure of AD. We already identified that was 136, which of course is a minor arc since it's less than 180. All right. So guys, this side was really dedicated to the measure of arcs and angles. The second side that we're going to look at right now is more dedicated to the length of an arc. So we're going to get a formula for this. looks like this, and it says the length of an arc, so that's an L, it's like a cursive L. The length of an arc is simply its degrees out of 360 times circumference, right? We know that 2 pi r is the circumference of a circle. So let me give you a little more understanding on that. So what they're going to ask you for is the length of an arc like this, right? The length of an arc. Well, understand that the length of an arc is simply part of the circumference, right? That's what an arc length is. So the length is simply part of the circumference. So what we're doing with this little piece of the formula is we're trying to understand how much of the circle it represents. And then we multiply that by the circumference. So for example, here's a real easy one. If the measure was 180, right? So just go with me on this. That's not this one, obviously. But if the measure was 180, right? Like maybe this one right here, AC. So if I wanted to know the length of that arc right there, well, isn't 180 degrees half the circle? So if this represents half the circle, then its length would have to represent half of the circumference. And so that's all we're really doing with this formula is we're figuring out how much of the circle does it represent, and then we multiply that by the circumference. So let's give this a try here. So x represents the degree of your arc, and r is obviously the radius. So let's jump down to these bottom 4. And I'm going to throw in the formula just so we always have it in front of us. So length is the arc measure out of 360. And we're going to multiply that by the circumference. All right, so if we look at DE, so here is DE. We can see that DE is 120 degrees, right? So that 120 goes right there. So we're going to say 120 out of 360 times the circumference. So guys, understand the big picture here for a minute. 120 out of 360, if you reduce that, it's 1/3, right? It's 1/3. So what we're saying is this arc, if it represents 1/3 of the circle, then the length would be 1/3 of the circumference. So we're basically multiplying 1/3 times the circumference. So how do we get circumference? 2 times pi times the radius. And on this one, they're telling us the radius is 2. So that would be our setup. Guys, there are 2 different ways they can ask you for an answer on this. They can ask you for an exact answer, and they can ask you for a rounded answer. So if they wanted the exact answer, what would that look like? Well, remember, this is 1/3. This is 4 pi. So if I bring those together, if I did 1/3 times 4 pi, that would equal 4/3 pi. And we could do that in a calculator. You certainly could. All right, if I did this divided by this times 4, it would look like this. Guys, in order to leave this as an exact number, I would have to leave it in terms of pi. I got to leave pi as pi because this is never an exact number. So if I were to go into my calculator and actually multiply all this together, it's going to be a decimal that goes on forever, right? So if they ever say, leave your answer in terms of pi, this is the way you want to leave it. Okay, you leave pi as pi. However, this one said round to the nearest hundredth. So we're just going to type it all in. I'm going to say 120 divided by 360 times 2 times pi times 2. So if we're going to round it, you can easily just type it all in the way that we set it up. Hit enter. There's our decimal. Guys, when you round, make sure you round carefully and accurately. If we're going to round to the nearest hundredth, that's the first 8 that we see. He's in the hundredths place. Well, the 8 behind him says we got to bump up that 8 to a 9. So we're going to round this to 4.19. if we round it accurately. So guys, most likely you are asked for rounded answers, and that's fine. But if they ever ask you to leave your answer in terms of pi, I just want you to know what that looks like. We'll do that again with one of these later on. Okay, what is the length of arc DEA? So D to E to A. So let's just start with the formula. The first thing we need to know is this guy. What is the measure of that arc in degrees? Well, from here to here is 120. From here to here is another 90. So we basically have to do 120 plus 90, which we know is 210. So the degree of that guy is 210 degrees. Out of 360. So we always want to multiply that by the circumference. Guys, notice on this one, they didn't give us the radius, they gave us a diameter. So one of the things that we talked about in the first lesson was there's two ways to write the formula for circumference. This is one way, 2 pi r. But remember, twice the radius is the diameter. Or sorry, twice the radius is your diameter. So the other way you can write circumference is diameter times pi. And that would be the same formula. Since they gave us the diameter on this one, let's just take that approach, right? So we're going to do the diameter times pi to get the circumference. So the diameter times pi. So just keep in mind that the circumference can be written as 2 pi r, but it can also be written as pi times the diameter. So let's go to the calculator and round this to the nearest hundredth. So if I do my 210 divided by 360, and then multiply that by 7 pi, that's going to give us our arc length. Guys, again, make sure you round accurately. If we're going to go to the nearest hundredth, that's where I see the 2. I look at the next number to tell me whether that 2 should stay a 2 or bump up to a 3. That 8 tells me I need to bump up this guy to a 3. So 12.83. Would be the arc length. All right. So on this one, again, I want us to practice two things. Let's see if we can write this in terms of pi and round it to the nearest hundredth. We're going to do both for practice because you are going to run into some of those. So we'll get a little practice doing that. So let's look at BE here. So you guys can see that BE is a diameter, right? BE is a diameter. So when they say that BE is 24, what they're really telling you is that the diameter is 24. So let's keep that in mind. Let's go to our formula. So we always want to start by figuring out what is the measure of the arc. So if I look at BC right here, so I know that BC is 45 degrees. So that's the measure. We're going to multiply that by the circumference. Since they told us the diameter, we're going to use that version of the formula. So pi times diameter would be 24 pi. So guys, I want to first try this as what would that look like if I wanted to just leave pi as pi, right? Let's keep it in exact terms first. So if I just did 45 over 360 and I multiply that by 24, I get 3. So in other words, 3 pi would be the arc length, right? So if they ever said leave your answer in terms of pi, that's what it would look like. If they wanted us to round it like this one is asking for, I could simply do the whole thing in my calculator and get the decimal. So 9.42 would be the rounded answer. Guys, do me a favor. In your notes, I want you to make a little side note to yourself. This is what an answer looks like whenever they say write your answer in terms of pi. Right, so whenever they say leave your answer in terms of pi, that just means leave pi as pi. Don't put pi in your calculator. Just leave pi as pi. All right, last one. We're good with the lesson here. So CBA. So we're going C to B to A. They could have just said CA. That's obviously a minor arc, so I don't know why they put 3 letters in there. They could have just said CA. But nonetheless, we're finding the measure of that arc. So we know this is 45. Guys, if this is a semicircle, if that's 90, then so is that. So we may have to fill in a little extra information from time to time. So the measure would be 45 plus 90, which is 135 out of 360. And we're going to multiply that by the circumference. So let's see what they're telling us right here. DO is 3. Well, if we look at DO, DO is obviously a radius. So by them telling us that DO is 3, what they're really telling us is that the radius is 3. So 2 pi r. And there's our setup. The rest is calculator work. So let's punch that one in. So if we put the whole thing in, it would look like this. Round that off to the nearest hundredth. We should be looking at 7.07. Make sure that you round accurately. So guys, that is what our section 2 looks like.